Can anyone give us an idea about the null? Let's read the question one more time. Is there significant evidence to conclude that the proportion of the first group is greater than the proportion of the second group? What do you think? What will be the alternative and what will be the null? Anyone? Is there significant evidence to conclude that the proportion of Nasonex users who experience such and such is greater than the proportion in the control group? So what will be the alternative?
P1 is greater than P2.
Perfect. So it's a one-tailed test and it's a right-tailed test. Okay. Now we have to test, before we continue, we have to test the normality and independence. The normality would be it is known that over 10 million Americans who are 12 years and older are allergy sufficient. Received. Okay. So is there significant evidence? So in order to determine whether the conditions are fulfilled for normality, so we have N1 times P1 hat, 1 minus P1 hat. And this has to be greater than 10. Then N2, P2 hat, 1 minus P2 hat. This has to be greater than 10. Where's my calculator? Buried. So N1, 2103. Parentheses times P1 hat. I did not determine it. Let's determine P1 hat. So P1 hat is 547 divided by 2103. So 0.26. And 368 divided by 1671, 0.22. It's easier. I can plug them in as is, but it will be easier if I just approximate that. So now 2103 multiplied by 0.26 and multiplied by 1 minus 0.26, and I got way more than 10. Okay, the other one, 1671 multiplied by 0.22, and in parentheses 1 minus 0.22, and I get 268. 286, which is definitely greater than 10. So conditions of normality are fulfilled for both samples. Now the independence. So we already are told that 10 million. So obviously, in this particular case, N is less than or equal to 0.05 multiplied by the entire population. So the N1 as well as N2. Even if we are only considering 10 million, as they are telling us, if you multiply 10 million by 5%, which is 0.05, you get 500,000. Our sample sizes are 2,103 and 1,671 respectively. Good, so now we are ready to conduct the test. Both conditions are fulfilled for both samples. Okay, again, go to Stat, Tests. This is a two-proportion z-test. And very simply, it's asking us to enter the data. X1, 547. N1, 2,103. X2, 368. N2, 1,671. And what are we trying to do is a right tail test. So make sure you select the correct direction, right tail test. You know me, I like to draw. Let me see if I have anything here. Yeah, I do have a function, so let me. And here it is. I got that Z statistic. By the way, Z statistic is all this calculation. P1 hat minus P2 hat divided by the pooled P, 1 minus the pooled P, square root, and then the square root of 1 over n sub 1 plus 1 over n sub 2. This is what the calculator is determining. So I got the Z, correct me if I'm wrong, I got 2.8393, and the P value as being 0.0045. $547, I'm checking again, 368, 1,600. And it's the right tail test, because I went in and out of the screen, so I'm not sure I got the correct answer. Okay, so it is correct, 2.8393, is correct, but P is 0.0023. Let's draw a conclusion, and then we look at StatCrunch. What is our conclusion? Remember, alpha was 0.05. Can anyone draw a conclusion for us?
I'd say it's not significant since it's less than 0.05.
It's statistically significant because it's less than 0.05. So let me explain just to make sure that this is clear. This is because it's a right tail test. Alpha is right here. This is 0.05. But this proportion is smaller than alpha. And it's this value here, which means that the test statistic is here. Z statistic is right here, this number. And we calculate the area to the right. The area to the right is the p-value. And all this area is rejection region. This is anywhere here is non-rejection. So p-value less than alpha, reject, H naught. And we will have to say that there is sufficient evidence coming from this particular two-sample situation that the proportion of people or patients with side effects, headache coming from Nasonex is greater than from the placebo group. Okay, so let's do this with StatCrunch now. I'm going to share. Oh, where is my mouse? Which mouse? I have three, because I have three devices. I don't know which mouse is which one sometimes. I have to look. Okay, so sorry guys, I have to move you. Wake up, wake up, wake up. Okay, so we go to stat, and this is proportion stats, but this time we're going to two sample. We do not have the data. We have directly the summary. Okay, number of successes for sample 1. I keep them in the same order. Sample 1, where's my data here? Okay, successes, where's my keyboard? Okay, X sub 1, in other words, 547. Number of observations in that sample, 2103. Number of successes in sample 2, 368. Number of observations in sample 2, 1671. Okay, so, okay, let me stop sharing for a second to explain what StatCrunch is doing. Sorry, guys. StatCrunch shows this null hypothesis like this, which is perfect. It's the same thing. And it shows the alternative hypothesis as P1 minus P2 greater than 0. It's the same thing. It doesn't matter which one you write. You can write P1 equals P2 or this, or you can write P1 greater than P2 or this. Back to sharing. Sorry, guys. Okay, so P1 minus P2 is 0. Now we want P1 greater than P2, which means P1 minus P2 is greater than 0. And I want to store the data. I want the p-value plot. I don't know what it's going to do. And I want to compute. And does it show? Yes, it does. So it does show the z statistic, as you see. Yes, z sub 0 is not usual or common notation. Is z statistic. What I showed from the beginning is the common notation, not z sub 0. For some reason, the book uses that. So the z statistics, z coming from this particular sample is this, exactly what we obtained with the calculator. The p-value is exactly this, what we obtained with the calculator. It's right here, starting from this point to the right tail, into the right tail, all this area. Okay, back to what it gave me here. Sorry, guys. However, I wanted, yes, I have it in the table. That's what I was looking for. So get out of the way. Okay, I can make it go out of it. But here is the p-value. Here's the z statistic again. It calculates the sample standard deviation, standard error, sample difference, P1 minus P2, and so on and so forth. Any questions on this? Do we understand the technique of conducting a test of hypothesis based on two samples coming from not only independent populations, but independent sampling? Now, we can continue by finding a, and this is very important, it's a very important interpretation. Let's continue with, it's item 3 on my handout, but I want to do it for this problem as well, and then we'll continue. So give me any confidence interval that you would like to create. You can say 90%, you can say 95%, you can say 99%. Just choose confidence interval. For P1 minus P2, population proportion 1 minus population proportion 2. Choose any of them, because I want to show you how to create the confidence interval. Which one will you want to conduct?
90.
90, perfect. So for the given information that we have right now in our calculators, we want to find a 90% confidence interval for P1 minus P2. And we have everything in there. So go back to stats, tests, and now scroll down carefully. We want 2 proportion z interval. It's B in my calculator. I'm not sure. I hope it's B in your calculators. So that's what we want to use. All the information is there. You don't have to type it in again. You just have to change the confidence level into confidence interval in 90%. So the 90% confidence interval for the difference between P1 and P2 happens to be 0.01695, comma, 0.0628. So here's what it's important to understand. Whenever we determine the confidence interval for the difference of the two proportions, this confidence interval does not, as you see, does not have 0 in it. So if I look at a real line, 0 is here, and the confidence interval is somewhere here. This is the confidence interval that you see here. This is the confidence interval. As you see, 0 is not inside the interval. It's outside the interval. What's the difference? Well, here's a big difference. If 0 is inside the confidence interval, we cannot conclude that there is a difference between the two, that one is bigger than the other. We cannot. But this time, we have in the confidence interval from this sample, we have a confidence interval that is consistently positive. It does not include negative values and positive values. In other words, it does not include 0. So this says that P1 is indeed greater than P2, coming from this sample. How come? Because the answer, P1 minus P2, is a number that is positive. That means that P1 must be greater than P2 in order to consistently get a positive number. You can say not by much. That's possible. But still, P1 is greater than P2. Now, if I have a confidence interval like this, so this is the lower limit, and this is the upper limit of the confidence interval. But as you see, it includes 0. I cannot conclude that P1 is greater than P2. I cannot conclude that P1 is less than P2. How come? Because some results are negative and some results are positive. Here, all results are positive, which makes P1 greater than P2. But if the results sometimes are positive, sometimes are negative, positive, negative, positive, negative, and even 0, I could never conclude that P1 is greater or P2 is less, because the results are either positive or negative, which means sometimes P1 is bigger, sometimes P2 is bigger. So that the answer is positive sometimes and negative sometimes. Okay, let's look at another confidence interval.